The fire safety requirements for buildings have developed historically on the basis of the principle of separation. The purpose of approved, tried and tested fire protection systems is to prevent the spread of fire. Approvals are granted on the basis of the results of standardized fire tests. However, it's impossible for standardized fire tests to precisely reflect the conditions found above all in existing buildings. Natural fire tests, on the other hand, offer an opportunity to test under real conditions during the course of day-to-day practice. Natural Fire Test 2.0 was carried out by the SVT group of companies under the scientific supervision of the Materials Testing Institute MFPA Leipzig. Generally speaking, passive fire protection for buildings requires certificates, test and suitability certificates based as a rule on standardized fire tests. In standardized fire tests we naturally look at scenarios that we consider to be fundamental. Naturally, these tests do not replicate the real conditions that we find in buildings earmarked for demolition or indeed in any actual buildings. They do, of course, provide us with some initial findings. However, the advantages of natural fire tests are that they enable us to observe and understand the progress of a fire within the framework of as realistic a scenario as possible. We take measurements and use the results as the basis for practical knowledge that is then put to the tests in the laboratory. The concept behind the planned natural fire test was explained during the course of an event held the previous night. Two different test buildings, one equipped with professional fire protection systems and the other lacking adequate or properly installed systems, were described in detail. The purpose of the fire test is to demonstrate the consequences of inadequate fire protection measures. The event was attended by over 100 specialists, customers and other interested parties. Despite the adverse weather conditions, they watched the fascinating outdoor event. Very few of them had experienced a real fire before. I would expect the fire bulkhead system being tested here to satisfy requirements and resist the fire. This would basically confirm that it is capable of providing the necessary level of fire safety in our building schemes as well as in other projects. We have already filled various shafts in the cooperative's housing stock with the granulate. Now we are being given the chance to see how it performs in a natural fire test. I'm very eager to see how the shaft filling stands up in practice. The first fire is therefore going to be ignited in a flat, whose service shafts contain no fire separation barriers. The contents of the shaft are in a highly critical situation. Ventilation ducts, cables and pipes are arranged in a solid mass, without the necessary distance either between each other or from the walls of the shaft. The shaft walls are covered by just one layer of plasterboard, 12.5 mm thick. Most of the ceiling penetration seals have been left open. Electricity sockets, air extraction vents and sewage hookups are all built into the shaft wall. In the wall area, substandard bulkheads around cables and pipes of the kind regularly found in real-life situations have been recreated. Ingolf Kotthoff, General Manager of MFPA Leipzig, gives the go-ahead for the first test. The fire load, consisting of a 1,150 kg stack of standard timber crypts corresponding to a calorific value of 786 megajoules per square meter, is ignited. The measuring equipment has been activated. After around 2 minutes, the smoke alarm goes off in the room in which the fire starts. The alarm on the floor above goes off after 5 minutes. Between the 5th and the 8th minutes, increasing volumes of smoke penetrate through the wall bulkheads with the result that after 9 minutes, visibility is reduced to 0. In the 12th minute, flashover occurs in the room in which the fire is started. In the room in which the fire originated, the conflagration is now fierce, and after around 19 minutes, the service shaft is filled with smoke all the way up to the 5th floor. In the 25th minute, the shaft wall on the 2nd floor burns through. After around 30 minutes, cables and pipes are also ablaze in the cellar. By the 40th minute, the surface temperature of the shaft wall on the 5th floor is recorded as having reached 200 degrees Celsius. By the 55th minute, the inadequate wall bulkheads have partly burned through and the flames in the room in which the fire started are visible through the boreholes. Via a service shaft that is inadequately protected against fire, fire and smoke spread throughout the entire building within a very short space of time. We are now in the room in which the first fire was started and want to see how the fire spread from here and what damage it caused. Here we see the service shaft of the first test fire. The plasterboard wall has failed and a lot of the installations within the shaft have also failed. The test readings indicate that the fire spread completely throughout 4 floors. Here we can see clearly that the fire and smoke were able to spread to the other floors, endangering the lives of the other tenants and inhabitants of the building.
Und eine Gefahr für Leib und Leben der darüberliegenden Mieter oder Bewohner besteht.
Furthermore, substandard bulkheads were fitted here around installations. It's clear that these systems have not helped to avoid the fire spreading from one flat to another. These inadequate bulkheads were incapable of withstanding the fire. And now I'm keen to see the results of the fire protection systems installed by SVT. The second fire is to be ignited in a flat with identical shaft contents and walls. Here, however, the connection to the ventilation duct has been fitted with a fire prevention valve and cold smoke barrier, and the service shaft cavity has been filled with non-combustible rockwool granulate, specially manufactured by the company Rockwool using air injection technology. The sealing apertures in the shaft have not been specially sealed. Single and combined bulkheads in the wall have been installed using SVT systems that have already been approved or are currently in development. Furthermore, within the framework of a development project, a ceiling cladding with insulation material has been fitted. Once the first fire test has been extinguished and the measuring equipment reinstalled, the second fire test is started. This time flashover occurs sooner, after around 8 minutes. Seen from the outside, the second fire is far fiercer, with flames leaping out of the windows to a height of around 6 meters. The firemen wearing special protective suits and the scaffolding on which they are standing have to be protected with water. Ultimately, the firemen are forced to move to safety. Outside the room in which the fire started, no critical temperatures are read. Neither in the flat above nor in the flat below is either smoke or fire to be seen. The shaft wall and bulkheads in the room in which the fire was ignited are tested to the extreme by the inferno. Have the systems functioned properly? Have they withstood testing? Hello Thomas, what kind of temperatures have you got for the surface of the plasterboard on the floor above the room of the fire? Well, Carsten, they are actually quite low. After 60 minutes into the test, the surface temperatures have increased by around 8 or 9 degrees, so no problem there. What an amazing result. So it's out of the question that the fire might have spread to the floor above? Completely out of the question. So the system worked. Absolutely. If you backfill it from bottom to top with mineral wool, which is the system SVT is offering and successfully implementing, that's a safe system. In this case, there was no spreading of the fire to the next floor. There was minimal spreading of smoke via the ventilation ducts, which were sealed, although this was triggered correspondingly late after melting. For us, the filling of shafts in existing buildings has shown itself to be a suitable alternative as a way of not having to undertake the complicated and expensive renovation of every single item of household utility equipment. The backfilling system allows traditional utility systems to remain in the shaft, providing the shaft is appropriately sealed, filled. All in all, this fire test is a fantastic, positive result for shaft filling.